Hi, folks. It's Mr. V, and today's lesson is a little bit of practice. It's some of the more mathy part of the proof business. We're going to actually put into practice the shortcuts that we've learned so far, the side, side, side and angle, triangle congruence theorems. And for a warm-up, we so you should be able to recognize when to use and to use these shortcuts in proof. And I'm not going to go through all of these, but I will show you a few of them. Part one is a warm-up where we use the triangle angle sum, the three angles that sum to 180. And you're supposed to put your answers in here, and then you can check your answers by clicking on this after you've done that. There's a few pages of this. This is kind of a warm-up more than anything. Next, we have this business of some notes on triangle congruence statements. If two triangles are congruent, all of their corresponding parts are congruent, and you have to line up the statements. Also, it's not always true that the converse of a statement is true, an if-then statement. But in this case, it is true that if the corresponding parts of two triangles are congruent, then the triangles are congruent. So the converse is also true. But you have to make sure that you get them in the right order. So the angles have to match up. If you said A, B, C, you have one tick, two ticks, and no tick. Here you would have E, D, C, which would be one tick, two ticks, and no ticks. So you have to line them up. And you can try this in a couple of ways. Then we come to this fellow. And you'll notice I have triangle ACT, so I'll put what it matches up with ION. So A matches up with I, C matches up with O, and N matches up with T. And I'll mark it like this. Between the 1 and 2 ticks, I'll put one. Between 1 and 2 arcs, I'll put one tick. I'll put 2 ticks here. And now you can see which parts correspond to which parts and which ones have to be true. So we could restate this. Instead of saying ACT is congruent to ION, I could say CTA is congruent to ONI, or TAC is congruent to NIO. Can you organize a way of doing this and find all 6 different ways of writing this congruent statement? That's the challenge in this particular activity. And now we come to one that's, I think, is interesting. That's because I wrote it, I suppose is why. But if I have triangle ABC, and we're told that it's congruent to ACB, well, A matches up with A, but B matches up with C. So these two angles would have to be congruent. And C matches up with B. Oh, this is isosceles. Similarly, we do this next one. If you have triangle ABC, I'll put A at the top here. If A matches up with B, these two angles have to be congruent. If angle B matches up with C, B's already got one tick on it. C would have to be congruent. And then C would match up with A. This is equilateral. Do you see how this triangle congruent statement business works? I'm not going to go through all of these, but I will go through a couple of these. In the next section, you're supposed to show which shortcut you could use to prove two triangles are congruent. And the given information is pretty much marked on all of these. But there's other information that is true that's implied, but it's not marked. And if you mark something on a drawing, you have to have a rule or something, a reason to support it. And some of the things to watch out for would be vertical angles. I'm not going to mark vertical angles are congruent, but if you look at your drawing, you can mark them and you can say the reason they are congruent is because they're vertical angles. Same with the radii of a circle, those are congruent. Unless you're trying to prove the isosceles triangle theorem, you could say, well, the base angles of an isosceles triangle are congruent. Or if it's a common side. We haven't seen this one yet. This is a common angle. And we also have the alternate interior angles or other angle relationships formed by parallel lines. And so, for example, here you have the common side. So you could use the side, side, side. Like I said, I'm not going to talk about each of these, but I will talk about a couple of them. In this one, we know the vertical angles are congruent. And that's good, except there is no theorem SSA. We haven't seen it yet. There is the theorem SSA sometimes. Is this one of those times? I can't answer that information. There's not enough information here. Some of these other ones, ones that need explanation. Here you have two angles that are vertical angles that you could mark. We don't have a theorem over here, AAS. And so, but I want to point out to you that if you know two angles of a triangle are congruent, so this one plus this third one have to add to 180. Well, in the same way, this one plus this third one have to be 180. So these other angles have to be congruent. This would be angle side angle. And that's something to watch for. That's something to watch for. If you have two angles of a triangle congruent, the third angles are also congruent. Here we have an isosceles triangle theorem. I could say that this angle at the base has to be the same. So I could use angle side angle. But notice I also have a common side here. So I could use side angle side for this. And this last one I think needs a little bit of explanation. It could be any one of these three. And my reason for that I'm going to give you now. This is part of the reason why I'm making this video, so that you can see this. Let's see. Base angles of a triangle are congruent. I'm going to separate the two triangles so that you can see them like this. And if I have an isosceles triangle, this angle and this angle would be congruent. That's this one and this one. We're given that these two angles at the top are congruent, and we also have a common side here. But there is no shortcut angle side, so, or at least we're not using the angle side. But if two angles of a triangle are congruent, the third angle has to be as well. So this would be angle side angle that I could use to prove these two triangles are congruent. I could use something else. I could say these two small triangles are congruent. Here we have, again, the angle. So this third angle has to be congruent. So I could use angle side angle to show that this triangle is congruent to this one. Now, that's not what I'm asked to prove, but if I prove this first, then I could say, well, these two sides have to be congruent because the corresponding parts of congruent triangles are congruent. And now, also the base angles of an isosceles triangle are congruent. So if I were to separate the two triangles, I have a common side with this one. That's a side. I have this one with one dot and a slash. So this is a dot and a slash. It's congruent to the one with the dot and a slash because we add those together to get the same angle. And then I have these two sides over here. So this is by side angle side. These two are congruent. The third way of doing this, again, if I prove that these two triangles are congruent because of the vertical angles, the angle side angle triangle is a shortcut. Now, the one that I haven't used is the side, side, side. So I'll redraw my triangles. Here's the one, here's the other. We have a common side here by CPCTC, because these two triangles are congruent. We have the sides here. It's congruent to this one. And then I have this side and this side have to be congruent because these two triangles are congruent. So I have the one with a one tick and an X is congruent to the one with the one tick and an X. So by the side, side, side triangle congruence theorem, these two large triangles, JKN and NMJ, are congruent. In the next section, we try to prove the isosceles triangle theorem. And this needs a little bit of explanation. We start with an isosceles triangle, and certain parts of it are true. So in the first one here, you're given that this is a segment bisector, and you have to prove it. And there's the words here that you can use and follow. The second one, I'm not giving you the words. You have to actually write them out yourself. And we're starting with an angle bisector. The one that needs explanation is this one. We're given that DG is a perpendicular bisector of segment CE. We're supposed to prove that angle C is congruent to angle E, which is the triangle, it is the isosceles triangle theorem. So we're trying to prove that this angle is congruent to this. We don't know that to begin with. All that we're given in this third one is that this is a right angle. Now here you have an angle that matches up with an angle. We have a side that matches up with a side. And we know that this is congruent to itself, so we have a side that matches up with its side. We do not have or understand the side-side angle theorem, sometimes theorem yet, but we do know something about right triangles. That's the Pythagorean theorem. If a squared plus b squared is equal to c squared, if I move the a to the other side, I get b squared is equal to c squared minus a squared. And I could also say that b, which would be in this triangle, if this is a, this is c, this would have to be b. B is equal to the square root of c squared minus a squared. And notice, we know that these two are the same. That means that these two sides have to be the same. So by the side-side-side triangle congruence theorem, the two triangles are congruent. By CP-CTC, the corresponding parts of the congruent triangles are congruent, which says that angle C has to be congruent to angle E, or the base angles of an isosceles triangle are congruent. Let's see if there's anything else. There's some other proofs here, some proofs that are less complicated, and you can fill in the blanks and you can see how straightforward and basic and easy these are. Further, we go down to part 6. Part 6 is some mathy questions, a little bit mathy. What is this page here? This probably should, okay. Here I'm given some stuff with an algebra in it. It's got an X in it. So if you draw the figures, mark the parts that are congruent, maybe you can solve for X, and same with this one. The last things, we have some challenging problems. Now, these are not challenging problems, real challenging. These are not advanced problems that I have for you. They're more advanced than the basic level, and maybe they need some explanation. Maybe they need some explanation for you to be able to do. If you'd like to see some advanced questions, you should ask me and I will show them to you. But for what we're doing, this satisfies what we're doing. So good luck and success.